Hello, today me, Ling Sushen, and my partner Anis Nabila binti Arashad will present for the Wurtzite structure. So, what is Wurtzite? Wurtzite is a brownish-black mineral zinc sulfide that consists of zinc sulfide in hemimorphic hexagonal crystal or a fibrous state, and that is polymorphous with sphalerite. Unicell and lattice type of Wurtzite. What is unicell? Unicell is the smallest repeating unit that shows the full symmetry of the crystal structures. Wurtzite is another type of polymorph of zinc sulfide. Wurtzite is a hexagonal lattice type derived from HCP arrays of anions with cations occupied in half tetrahedral holes, which is T plus or T minus field. Unit formula Z. Unit formula is the number of ions or atoms which found in a single unit cell. Now, we'll see how to calculate the unit formula. Z of S2 minus is 8 columns times 1 over 8 plus 1 center times 1 equal to 2. Z of zinc 2 plus is 4 edges times 1 over 4 plus 1 center times 1 equal to 2. So, the ratio of S2 minus to zinc 2 plus is 2 to 2. Thus, the unit formula for Wurtzite is 2. Location of each atom or ion in Wurtzite structure. The yellow one indicates S2 minus ion and the blue indicates zinc 2 plus ion. There are total 9 S2 minus ion, 8 at the corners, which 4 at the top and 4 at the bottom, and 1 at the center. Zinc 2 plus occupy half tetrahedral site. Zinc 2 plus will occupy 5 tetrahedral site, which 4 at 5 over 8 and 1 at 1 over 8, or occupy another 5 tetrahedral site, which 4 at 3 over 8 and 1 at 7 over 8.
I love cold drinks, especially the ones that have ice in it. Talking about cold drinks, do you know what type of crystal structure is ice? Since we consume ice every day, let me explain. Ice has hexagonal form or shape. The underlying crystal structure of the oxygen atoms in the crystal is known as Wurtzite, which is the general name given to this particular type of hexagonal crystal, which means ice has a Wurtzite structure. Plus, the H2O has the HCP, which has 8 corners and occupies the tetrahedral site. Wurtzite structure is very open. That's why ice has lower density than water. There are many examples of Wurtzite crystal structures, such as silicon carbide, beryllium oxide, and also aluminium nitrate.
Moving on, let me explain about the coordination number of Wurtzite. This is a zinc sulfate. In Wurtzite, both cations and anions have a coordination number of 4. This means each ion is surrounded by 4 nearest neighbors of the opposite charge. This occurs because cations, like zinc, occupy half the tetrahedral holes within a hexagonal close-packed arrangement of anions such as sulfur. This specific tetrahedral arrangement maximizes attractive forces between oppositely charged ions and minimizes repulsion between like charges. This results in a stable Wurtzite crystal structure. The empirical formula for zinc sulfate is ZnS. This means it shows the simplest whole number ratio of atoms in the compound. In zinc sulfate, one zinc Zn atom forms an ionic bond with one sulfur S atom. Since zinc loses 2 electrons, Zn2+, and sulfur gains 2, S2- to achieve stability, a 1-to-1 ratio between balances the charges, resulting in the most basic formula representing the compound. Moving on, the applications of Wurtzite in life. There are two applications of Wurtzite. The first one is in biomedical field and the second one is in optoelectronic field. In biomedical field, it acts as an active site where biological events occur, subsequently defining the sensitivity and stability of a device. For example, in a biosensor is a device that measures biological or chemical reactions by generating signals proportional to the concentration of the analyte in the reaction. As for the optoelectronic field, due to similar size of host cation Zn2+ and a transition metal, zinc sulfate-based DMS can be easily fabricated. Zinc sulfate semiconductor has been considered as the best host material. When incorporated with transition metals such as V, Cr, and I for obtaining room temperature ferromagnetism. For example, in a LED, which is light emitting diode. LED is the quantum mechanical effect of light on electronic materials, especially semiconductors. In conclusion, the Wurtzite structure is a hexagonal close-packed arrangement of atoms with alternating layers, commonly seen in materials like gallium nitride and zinc oxide. This structure influences the properties of these materials, affecting their electrical, optical, and mechanical behavior. Understanding crystal structure is incredibly important. In simple terms, crystal structures are like a blueprint for a material. By understanding this blueprint, scientists and engineers can unlock the secrets of a material's behavior and design new and improved materials for various purposes.